Everyone, today we will discuss a case study about the control of the distillation column. Let's firstly read the problem statement. Firstly, we should draw all of the control loops on the distillation column. Then secondly, what we will do is that based on the given 6 problems, as a process engineer point of view, we will propose some solutions to troubleshoot these problems. Firstly, we should start with sketching the control loops of the distillation column. So let's start with that. Before doing that, we should firstly identify which are the controlled variables in our distillation column. Generally, our controlled variables are pressure and levels in the bottom of the distillation column and the accumulator, and then we should also control top and bottom composition and flows. So let's start with sketching our distillation column. Let this be a feed, and in the feed we should have a control valve. So this feed enters our distillation column, which we can sketch like that. So top of the distillation column, which means it's vapor, overhead vapor, enters a condenser. So in different cases, this condenser can be a total condenser or a partial condenser. In our problem statement, what we have is a total condenser. So here we know that all of the vapor before the condenser will turn to liquid with the same composition, but only with the change of the phase. This also enters after the condenser. Our liquid enters to the reflux drum, which can also be whose name can also change as accumulator. Here what we have is our reflux drum, and from reflux drum we have two separate streams. One of them is sent to back to column, which is called a reflux, and the other goes to our further downstream equipment. This is the distillate product that we draw from the distillation column. So this is the distillate product, D. And if we look at the bottom of the distillation column, we can see that this liquid product at the bottom of the distillation column enters a reboiler. So this reboiler are generally considered as a partial reboiler. In some other cases, some rare cases, we can also have a total reboiler, but having a partial reboiler is a general case, okay? Reboiler. So in this reboiler, what enters the reboiler is our liquid bottoms of the distillation column. And here, due to a partial boiling, some of the liquid will turn to vapor and will be sent back to the column as a boil up. So the name of this stream is a boil up stream, and the other liquid product that we will draw from distillation column is called the bottoms, and this is also a liquid. So here we can also sketch another control valve here, and in the boil up we can also have another control valve. Okay, let's start with the pressure. We should know that we measure the pressure from top of the distillation column or from the top vapor product line, because vapor amount generally associated with the pressure of the total column. What it means is that the more vapor that we have in the distillation column, it means whole pressure, operation pressure of the distillation column will increase. So let's draw like this. Firstly, we have a PT which measures our pressure here, and it is connected to pressure controller. And how we can control a pressure generally in the distillation column? If we have a total condenser in our distillation column, the general strategy is to control it with the condenser duty. So for pressure, we will use condenser duty. How we can manipulate the condenser duty is by manipulating the flow rate of cooling water that is supplied to our condenser. So in the cooling water supply line, so let's draw some line like this. Let's put a control valve here. So we will connect this PC to cooling water supply line. And of course, at the end, we also have a cooling water return line too, but it is not our interest. So how we control, the philosophy is like that. Imagine we increase our cooling supply to our condenser. So the more cooling water that we have, more amount of vapor that enters our total condenser will be condensed to liquid. So we will have less vapor inside the top product line of our distillation column. And consecutively, as it is connected to the distillation column itself, inside the distillation column, we will have less vapor. What it means is that we will have less pressure. It has a direct effect on the pressure. So that is one scenario. In the second scenario, if we have a partial condenser, we can also connect it to the flow rate of our venting line. In this case, if we have a partial condenser, we will have another vapor stream from our accumulator. So by manipulating this flow rate of vapor that exits the accumulator, we can also regulate the pressure. So that is how we control the pressure, basically. Let me erase these parts. For the next point, we will look at how we can control the levels inside the distillation column. Firstly, we should determine which levels are we looking. In general, in distillation columns, we will look into two kinds of levels. The first one is the bottom level. So remember that in the bottom of the distillation column, we always have some level of liquid, and we should control this amount of liquid because we don't want our distillation column to run dry without a liquid or without a supply of vapor. So what we do is we are firstly measuring our liquid level with liquid transmitter that we fix at the bottom of the distillation column. Let's put a liquid level controller here. And how we can do it is very similar to the control of level inside a plain storage tank. Imagine we have a simple storage tank and we want to control its level. How we do it? We put a control valve in the liquid outlet of our storage unit, and that is how we control it. Similarly, what we can do here is controlling the level of distillation column with the bottom's product. So how we control bottom level? We are changing the flow rate of bottom's product. So let's connect it like this. Okay, we connected our liquid level controller to our flow rate of bottoms. The second level that we should control is the level inside the accumulator or inside the reflux drum. We always have and we should always keep some amount of level in our accumulator because we don't want, if due to some malfunction, if we lose our level inside the reflux drum, we will lose our reflux and it will change the temperature inside our distillation column. So we don't want that, and in order to avoid this problem, what we do is we keep some amount of level here. And if we look at the control of this, let's see, we have LT here and it is connected to level controller, and basically similar, very similar case can also be applied here. We have some kind of storage tank that is filled with some liquid level, and how we control it is we put a control valve in the liquid bottoms and we control it with the flow rate of this liquid line. In this case, this liquid line is our distillate product. So how we control accumulator level is manipulating the flow rate of this distillate product. So let's do that. Okay, we are finished with pressure and level. Now, what we should also, what is also a very important point is that we should control top and bottom composition, which means the composition of distillate and the composition of bottoms. So how we do that? We are firstly finding a representative physical property to control, and in often cases, this physical property is a temperature. So in order to control the composition of the distillate, we should manipulate the temperature of the first tray that is available in our distillation column. So basically, how we do it, let's put a temperature transmitter here, and it is also connected to temperature controller, let's say. And one of the basic things, one of the basic rules that we can apply here is control the first tray temperature with the amount of reflux. So temperature of top should be controlled by flow rate reflux line. We should connect this our temperature controller. Okay, this is how we control the top temperature. And we should also control the bottom temperature. And similarly, how we can do that? We know that the main energy supplier to our distillation column is the utility that we use in our reboiler. In often cases, this utility is steam. And we know that we can increase the bottom's temperature with the increase of the flow rate of this steam. So what we do is that we are putting temperature transmitter here to measure the temperature, and we are fixing it to temperature controller. And let's add some steam supply line here and connect this temperature controller to that steam supply line. So how we control bottom temperature with flow rate of steam. And lastly, last point that we will make is about the flows. Basically, the main flow that we can control in this case is the feed flow, which is also called a throughput control. Throughput control. So here it is very simple. We are adding a flow transmitter here, and we fix it to our flow controller and connect it to our control valve. And as a note, I should say that inside of each of these temperature, pressure, and level loops, we can cascade it to local flow controllers. Now in this slide, we will focus on the problem troubleshooting part, and we will specifically focus on the 6 problems that is mentioned here. The first problem that we will see is the low pressure case. Low pressure means that in the distillation column, and usually in the top of the distillation column, we have less vapor flow rate than it is needed. So less vapor flow rate. So our action should be correlated with increasing the amount of flow rate. Increasing vapor flow rate. So how we can do that? We know that the vapor balance in the distillation column is kept due to creation of vapor in the reboiler and the condensing of the vapor in the condenser. So as the condenser will have more direct effect on the vapor amount, we will start with playing with the condenser duty. So the first action that we should take should be decreasing the condenser duty and consequently decreasing the cooling water flow rate. These two actions will cause the decreasing amount of vapor in the condensing part. So we will decrease the amount of vapor that is condensing in each second. So we will have more vapor in the overhead part. So as we will have more vapor, it means the pressure will increase. Also, we can decrease the side stream flow rate. Why it is effective? Because by decreasing the amount of side stream flow rate, we can increase the amount of liquid in the trays. So this will also contribute to creation of more vapor in the distillation column as we have more fluids, and it will also increase the pressure. And what other what is the other contribution of vapor condensing is, of course, the reflux, because it causes the internal condensing of the heavy materials in the vapor stream. And as we increase the reflux, it will also cause increasing the vapor rate, so we will get higher pressure. Let's look at the second part. In the second part, we have high pressure, and it means we have more than enough vapor in our distillation column. What it means is that we should decrease vapor flow rate. How we can decrease the vapor flow rate? Of course, again, with the condenser. If we increase the condenser duty, it means more of the vapor from the overhead of the distillation column will be condensed, so we will get decreased amount of flow rate on the overhead of the distillation column. And similarly, if we decrease the amount of reflux to the drum, we will have more amount of liquid and less amount of vapor in the distillation column. But here, the specific care should be taken, because as we decrease the reflux, it means our top vapor can get heavier. And the third problem is about distillate being more heavier. So this is also correlated with the troubleshooting procedures that is mentioned earlier, and how we can solve that if the distillate gets heavier. Being heavy vapor and distillate means that we do not have enough vapor liquid equilibrium in the top trace. So how we can increase this amount of vapor liquid equilibrium is, of course, with the increase of reflux. Increase of reflux will ensure that we have increased amount of liquid in the top trace, and more liquid will be in contact, more or lighter liquid will be in the contact with the vapor, so it means our distillate will be more lighter after this procedure. Or we can decrease the reboiler duty, and this decrease in the reboiler duty will cause less vapor coming from the reboiler to the distillation column, so it means less heavy components that is concentrated in the bottom of the distillation column will go up. So this will cause our distillate for getting lighter. Let's look at the fourth problem. In the first part, we say our problem is that our bottoms gets lighter. It is very similar problem, but with the bottom of the distillation column. So how we can do that? If our bottoms gets lighter, it means that we do not evaporate enough amount of light components to the top of the distillation column, and light components which shouldn't be concentrated in the bottom, in fact concentrates in the bottom of the distillation column. So what we do, we increase the reboiler duty, which means that we increase the steam flow rate or steam supply to the reboiler. With increased steam supply, we evaporate more amount of liquid that is available in the bottom of the distillation column, and of course this evaporated part contains lighter compounds. So we can solve this issue. Or one problem that give rise to bottoms get lighter is that maybe we have excess amount of reflux here. It means excess amount of cooling is available in the distillation column, so more light compounds is getting condensed in top trace, and they go to the bottom of the distillation column, and which consequently makes the bottoms more lighter. Therefore, we can decrease the amount of reflux to the distillation column. And consequently, lastly, what we can do is increase of the side stream flow rate. The increase of the side stream flow rate will take away some of the liquid parts on top of the trace, so which means more amount of light components that is available in the vapors at the bottom trace will go up. It means we will have more heavy bottoms. If we look at the temperature of the column, firstly we will look at the column temperature at the top increased. Increased temperature at the top means that we do not have enough cooling at the top of the column. And what supplies the cooling to the top is, of course, the reflux. If we don't have enough cooling, it means that our reflux amount is not enough to cool the liquid on the top trace. So what we do is we increase the reflux rate, and as we increase the reflux rate, we will have more cooling, and with more cooling, we will have decreased amount of temperature. And lastly, if you look at the column temperature at the bottom, if the bottom is increased, if the temperature at the bottom is increased, it means excess amount of steam is supplied to the bottom of the column. Because remember from the control, the bottom temperature of the distillation column is directly controlled with the flow rate of steam. So if we have excess amount of temperature, it means we also have excess amount of steam. So what we can do is we decrease the steam supply to the reboiler.